Okay, let's look at number 10 first. This whole the question here, they ask you to do the differential from this book is from the Princeton Review, the page 122. They ask to find out the derivative of the following expressions. Okay, and derivatives like the number 10. I put number 10 here. The function fx equals to 2 times by square root x. This is square root x. Better way at this time, put it as what? X 1/2 power. Because the power here for the x is 1, and then the roots here is 2 here. So that's why we write like this way. Why we write like this? Because it's easier for us to use what we call that the power rule, okay? So we use the power rule to do this now. So f derivative of the x equals to 2. 2 is the constant, leave it aside when you do the derivative. So we just basically do the derivative of this part now. So the 2 times by derivative of this equals what? 1/2, put in front. And then the x, you have 1/2 minus 1, right? That's the power rule. And then this half and 2 cancel each other. So you have x, this half minus 1 is -1/2. And then this is accepted answer already. Of course, if you want to simplify further, it's fine. You can put it as 1 over x positive exponent, right? And then if you want to continue to do more work, it's fine. You can write it as back as what? Square root x. You want to rationalize, it's fine. So you time both numerator and denominator by the square root of x. So you will finally get square root of x over x. This is the answer, and I think this is also acceptable answer. It depends on the instruction of the question, okay? So generally, the key part here is this. Write the square root of x as x 1/2 power. That's the key parts, all right? So, and let's continue apply this methods. Oh, not yet done yet, because we need to find the x equals 9, right? So from here, you can put what? X equals 9. You will get what? Square root 9 over 9. That would be 3 over 9 equals 1/3. Actually, this is the answer, okay? Because they ask you for that point, x equals 9. What's the derivative of the function, all right? Now, similar methods, we do number 11, okay? 11. I rewrite the 11 as the power easier for polynomial with write the function as what? The form easier for you to do the derivatives, okay? So this is the 5 here, and then you have 2 times by x, and this is what? 1/2 power, like this, right? But before you do derivatives, try to simplify as much as possible when you do the derivatives. That will be easier for you. So this is just algebra work. So I can put like a 5, and this is 2 to the 1/2 power, and the x to the 1/2 power, right? Now, after this, we can get what? This one is a 5 times by 2 to the 1/2 power. That's just a square root 2. I leave it like this. And then put the x on 1/2 power, right? So when you do the derivative of this time, you simply what? Because this is the constant, we don't care about that. We simply what? We simply put it in front of it, right? The 5 square root 2, and then we time the derivative of this one now. Power root, we have a 1/2 in front, and the x 1/2 minus 1. So eventually we got a 5 root 2 over 2 and times by x negative half power, right? At this moment, we put what? X equals what? 8, right? They told you x must be equals to 8. So we make x equals 8 now. So we can get what? F derivative of the 8 will be equals to 5 root 2 over 2 times by x half. So that means what? 8 to the negative half power, right? So this one you can simplify further. So you can get what? 5 root 2 over 2. Times by this one is 1 over square root 8, like this, huh? Because negative power, we can flip it down, right? And then you can continue 5 root 2 over 2. Times by this one is 1 over 2 root 2. We simplify, okay? And then this two cancel. So you have what? 5 over 4. That's the answer, okay? The similar like the previous question, we just change, the key part still what? Change the square root of x to x to the half power, okay? That's the way we do this one. Now we continue work on the number 12. 12 is this, fx equals what? Sine x, right? So when you do derivative, so f derivative of the x will be equals to what? Cosine x. But this time you have to put what? X equals to pi over 3, right? So when you do that, you're gonna have what? Cosine pi over 3. Cosine pi over 3, what's the value of that? Let me show you how to get it. Of course, you can remember the formula to do this, right? But I show you use the chart, quickly find this one, okay? This is the x, this is y, like this, huh? Pi over 3, that's 60 degrees. So you can go like this one. See, this is 60 degrees. That's pi over 3. This is 90, and then this is 30, this is 30. So we have a 36, 90 triangle right now. So if I said this one is the 1, and this one will be root 3, this is 2, right? So cosine pi over 3. So that will be what? Adjacent over hypotenuse. Because that we have this x over y, right? No, x over r. X over r, that will be the, we call it as what? Rate. This one, this is the r, right? Adjacent over hypotenuse, or x coordinate over the r. So that will be 1 over 2. So we can find this now, okay? The step here is important here is sine derivative is cosine. And we know that cosine derivative will be what? If you have cosine derivative of the x equals negative sine x. So this basic trig differentiation formula we need to remember, okay? That would be helpful. Now we did number 12, and then 13, 14 is easy. Just use the power rule, right? And then the 15 now here. The students ask for the question of the 15. 15 is this here. Let me put it up a little bit. Okay. The 15. When you do the 15, the key part is this. Still need to change this one in the power form, exponent form, okay? Exponential form. So let me put number 15 here. 15, right? So you have fx equals to 1 over x. X is the first power. But I can write it as negative exponents, x negative 1 power. That'll be easier. Okay, this way will be easier than using the quotient rule. So we do derivatives equals what? -1 put in front. X -1 minus 1. Because I'm using what? The power rule. X to the n power derivative equals what? N, and then x n minus 1. This is the formula we're using for all those questions, right? So here we got what? -1. This one's x -2. You can write it as a -1 over x squared. That's the fine. Of course, you say, hey, I do not like to use this power rule. I would like to use the quotient rule to this one. I can show you here, okay? The quotient rule is this. If you do derivative of this one, you will get what? Derivative of the top, which is 0, times by the bottom, and minus, keep the top value of the 1, the derivative of the bottom is 1, over the bottom of 1 squared, right? And then 0 times x is 0, minus 1 times 1 is 1, that's -1 over x squared. Still got the same answer as this one, okay? So let's move on, go to next question. Okay, let's look at those two examples. Then this is the following two questions I'm going to explain, okay? The first one here, they said limits x approach to 5 equal this one, right? This is the function here. When you do this one, this is multiplication. So when you multiply two parts of the function limits by the property of the limits, you can change it to what? Limits to the first part, which is this, and then limits to this part. And here, no matter x approach to 5 from left side or x approach to 5 from the right side, it's the same value here, same value here. So that's what simply plug it in, okay? Because this one and this part of the expression, this expression is continuous at x equals 5. So you have just simply go 5 squared plus 1, and then we time by square root 5 minus 1, right? And when you do this one, 25, this is 26, times by this one will be square root 4. So square root 4 is 2. 2 times 26 equals 52. That's this answer, right? For this one, just simply use the property of the limits, separate them first. Of course, if you do not separate it, still good. For example, without doing this part, okay? Without doing this part, simply go here. You plug in, you have what? Since this is a continuous, so just plug in. Plus 1, like this, right? This one. And then time by square root 5 minus 1. And then still you get what? 26 times by square root of 4 equals 52. The same, okay? So then let's go to the second one now. The second one, the fast way is this. You can go by approach, let x approach infinitive. Imagine when x approach infinitive, only the x to the 10th power, the highest power dominates. The highest power, x to the 10th power dominates. So all the others, just put at 0. So the fast way will be what? Directed from here, you will get what? You will get neg limits x approach infinitive. Because x is a huge number, 10th power will be what? Way bigger than the 5th power and 3rd power. Way bigger than 8th power and the 4th power. So you can ignore all those. You can ignore this. You can ignore this. And then you will get what? Only -3x to the 10th power over 33x to the 8th power. Okay? And when you do that, this -3 over 33 is just -1 over 11. And the x squared, x 10th and x 8th cancel each other. You have another x second. So you have x second power there. And then you still have what? Limits x approach to infinity. Now, when x approach infinity, this part is positive infinitive, always. No matter x goes to negative or positive infinitive, this is positive. But time by negative number, so it's negative infinitive. So that's the answer, okay? Of course, you say, hey, I just want to look at more about this without directly cancel this part. It's fine, okay? Let me show you how. What we're gonna do is, we still keep this part, okay? We keep this part. And then we're going to do is, actually this is the answer already, huh? I just show you the alternative way, but that's a longer way than this one though. You can go, this is limits, x approach infinitive, and you take what? X 10th, x 5th, and x 3rd. The greatest common factor is x 3rd. Take it out. So you have -3x to the 7th power minus 70x second power and the plus 1 of this. The bottom one, do the same thing. X 3rd power. No, x 4th power now. Okay? You can take x 4th power. So you have what? 33. So you have a 33 times by x to the 6th plus 200 x to the 4th minus 1000 here. But when x approaches infinitive here, be careful here. When x approaches infinitive, you will have this is ignored. And it's still the same. The square and the 7th power, this dominates no more. The 6th power and the 4th power, 6th power dominates no more. So only, and then this one's going to cancel. This is the 1, this is the x, right? So you will get limits x approach to infinitive. Then you're going to have what? -3x to the 7. And then you have bottom one is 33. X and x6 will be x7. Still got what? This one cancel, so you have -1 over 11. Okay? But here, there's a typo here. There's a misread right here. This one, the bottom one, if you drop this part already, so you have an x 10th. This is not an x 8th. Be careful here. So this one should be x 10th. So if x 10th there, here, if x 10th here, this is 10th, this 10th, you cancel each other. So that means what? They do not have this. Okay, that's not bad here. You see that? So from here, we got this one, and then this one, we should get what? The same answer here will be -1 over 11. Same as this one. Okay, there's a little bit of miswriting here. It's like this. We think this is a highest leading, we call it leading term. The highest degree term, we call that leading term. So leading term, which is the highest power term, they are dominating compared with the lower power exponent of the x term. We cross them now, no need. So we have this one over this one. And then both of them got 10 as the power, you can cancel. And then what's left over is this. And if you go longer where you factor it out, you still do the canceling and the drop off the lower term, you still got the same. But I think this is the best way to do this kind of question, okay? When you have fraction, polynomials, we just keep the highest power term only for the numerator and the denominator, okay? So if you have any questions, please let me know. Thank you, bye-bye.